Okay, so which of the following must be less than 1? So the must is important here because it kind of dictates how I'm going to approach this strategy. I'm going to see if I can make these greater than 1. If I can't, then I accept the fact that they must always be less than 1. So I'm playing devil's advocate, and that's a really powerful way to evaluate min-max problems and a lot of questions on the GMAT in general. So I know that R is between 0 and 1, and I've set up this grid on the right-hand side, and I just want to assume that the min value for R is something like 1/10. And the max value for R is something like 9/10 since it's less than 1. Now the min value for S, which has to be greater than 1 but less than 2, the min value would be something like 11/10, which is 1.1. And the max value would be like 19/10, which is 1.9. Now, looking at these values, what would maximize statement 1? Because what I'm trying to do is force it to be larger than 1. If when I maximize it as much as I can, I still find that I can't get it to be greater than 1, then it must always be less than 1. So in order to maximize statement 1, I would want R to be as large as possible, 9/10, and I would want S to be as small as possible, which would be 11/10. Because in order to make a fraction larger, you want to increase the numerator and decrease the denominator. And what we see here is we still have a smaller number over a larger number, which means this is still less than 1. And that means that this is actually a correct answer. This always must be less than 1. The second statement, does R times S have to always be less than 1? In order to maximize this, to try to force it over 1, I'm going to want to maximize both parts of this equation. So I'm going to do 9/10 times 19/10. And what I'll get here is 100 on the bottom and something pretty close to 180 on top, because if it was 9 times 20, I'd end up at 180. So the top here is going to be, and we could actually solve it out, but I'm just showing because we can do some rough math here, it's definitely greater than 1. So this does not have to always be less than 1. So that's out. What about S minus R? In order to maximize the value of this to try to force it over the value of 1, I'd want to maximize my S and I'd want to minimize my R. And in doing that, I still end up with 18/10, which is greater than 1. So this does not have to be greater than 1. So the only one that must always be less than 1 is the first statement, and that leaves us with answer choice A.